Alright, hi guys, we're going to do a video lesson this weekend on motion on a line. We're going to review how to do position, velocity, acceleration problems. So, every year there's problems on the free response about this, about something moving from left to right or going up and down, and that would be motion on a line. So we've got three things we study. The first one is called displacement. And we're going to write some notes about these. And we know that displacement is the net change, I'll write the little delta symbol, net change in position. Net change in position. A lot of times we call it x of t, but it doesn't have to be x. And this is called the position function. So here's our position function. But what the position function really is it's x of b minus x of a. Where were you standing at point A, or where was your car at point A, and where was your car at point B? Subtract it and you'll know the distance that you traveled. So the position function, it'll find the change in position if you're doing displacement. It can be positive or negative. So it can be positive or negative. And the units that you're measuring in will depend on the story, but it's a distance, it's a position. So its units are like feet, miles, meters, etc. Those types of things. Yards. And those would be the units. If we step it up a notch, after displacement comes velocity. And velocity and speed are in the same category. Some people are really getting confused on that still. Speed is just positive velocity. It's the absolute value. So they're kind of in the same category. There's two types of velocities, but they both represent change in the position. So change in position over change in time. Over the change in time. How far did you go with respect to time? That's what velocity is. So you can calculate an average velocity, or you can calculate an instantaneous velocity. Instantaneous velocity. Both of which have the same type of units and everything, but average is like a secant line. It's delta x over delta t. So we would write it out, it's x of b minus x of a all over b minus a. You don't actually need a derivative to find the average velocity. An average person can do this. So no derivatives, no calculus needed. Instantaneous is one moment in time. That's where you need x prime, the derivative of position, which is equal to velocity, v of t. And so, of course, you can have positive and negative velocity, so can be positive or negative. And the units are things like miles per hour, I'll put mph, or meters per second, feet per minute, etc. These are the type of units you would get. Then we go one more step up and we get into acceleration. But before we write a note about acceleration, a couple more things about velocity. First of all, if velocity is greater than 0, positive, we know the particle is moving to the right or up. And if velocity is less than 0, negative, then we know it's moving to the left or down. If velocity is equal to 0, then we know the object is stationary. Anytime you're reading questions about something moving left or right or up or down, I think about velocity. Velocity's sign, positive or negative, tells me what I need to know. If I'm wanting to know if something's speeding up or slowing down, we should make a special note about that. The last packet, you actually had a question about this. So here's our special note. If velocity and acceleration, a of t, are the same. I'm going to underline the word same here. If velocity and acceleration are the same, so what I mean by that is they're both positive or they're both negative. Both positive or both negative. Either way. If velocity and acceleration have the same sign, they're both positive or both negative, then the object, whatever's moving, then the object is speeding up. If velocity and acceleration are working together, have the same sign, they're both positive or they're both negative, then the object is speeding up. If velocity, v of t, and acceleration, a of t, have different signs and they're working against each other, then the object slows down. So if velocity and acceleration have different signs, one of them's negative and one of them's positive, either or, it doesn't matter, but one of them's negative, one of them's positive, then the object is slowing down. Then the object is slowing down. So anytime you read a question that says, is this car speeding up or slowing down? Is the particle slowing up or speeding down? You're going to use this. You're going to look at this and say velocity and acceleration. They're going to tell me how to figure this out. So that's an important note. And then let's talk about acceleration for a second. Acceleration is our next derivative. And basically, we usually denote it as a of t. But that's really the derivative of velocity, which is really the second derivative of position. You can have positive or negative acceleration, so it can be positive or negative. And the units are meters per second squared, feet per minute squared, yards per hour squared, etc. These are what the units look like. So we're kind of just refreshing our memories. I think we're ready to jump in and look at an old AP question. So let's do a problem. Here's our example. A particle moves along the x-axis so that its velocity at any time t for 0, less than or equal to t, less than or equal to 16, is given by v of t equals e to the 2 sine of t minus 1. At time 0, the particle is at the origin. This is the introduction to the problem. So you might pause the video and write this down, but we're going to jump into the questions. Part A. First question is, can you sketch a graph of velocity? Sketch the graph of v of t. Sketch the graph of v of t. And we're in a calculator section, so you get to use your calculator. This is going to be an easy thing to do. We just want to plug it in, basically. So I'm going to turn my calculator on, go to my y equals, and I did this earlier, and I'm going to type in the equation, e to the 2 sine of x minus 1. So go ahead and type yours in, and let's graph it. Now, if you're using a regular graph, here's what mine looks like. It's a little crazy looking, but before I draw the picture, you need to modify your window. According to this problem, we are looking at time goes from 0 to 16. So 0 to 16 seconds or 0 to 16 hours, we don't know the units. But I need to change my window. I'm going to hit window, and I'm going to change the x-axis. Negative 10 to 10 is not necessary. We want to go 0 to 16. That'll be a much more better window for our problem. So from 0 to 16, I'll graph it. And here's what it looks like. It's a funky graph. So basically I'm going to copy this from the calculator and get it on paper. So I'm going to draw my x and my y axis out to 16. And if you kind of study it, I'm going to make this easy. I'm going to go 4, 8, 12, 16. Make it look like this. It looks like on the graph, the highest point, well, we can use our calculator. Let's use our calculator. What's the highest these peaks get to? I'm going to go second trace. And do you see the option that says maximum? We're going to find a max. And it'll ask for a left bound and a right bound. So I'm going to scroll to the left of one of these peaks, hit enter. And then I'm going to scroll to the right and hit enter, enter. And this top peak is at 7.853. So for my graph, when I draw this, I know I really don't need to get above like 8 on the axis. So I'll make it look like this. So it looks like it starts at 0, goes up to its first peak, comes back down a little bit before 4, dips down, goes back up, dips back down, and goes back up, and dips back down right around 16. I should have said this is 16. I don't know, something like that. It's not the best graph, but there's my velocity. Part B says, okay, new question. Oh, and I better label this. This is t for time, and this is v of t for velocity. I don't have any units. Part B is now, during what interval, during what intervals is the particle, during what intervals is the particle moving left? During what intervals is the particle moving left? So the second I read this, I'm thinking left means velocity is less than 0. It's negative. And I have an equation for velocity. It's e to the 2 sine of t minus 1. And I want to know when's it less than 0. So to figure this out, I'm going to solve. I can look at the graph and kind of see when this happens. If I look at the graph, velocity is less than 0 down here, and down here, and stops right there. So I see my intervals. I see kind of where it's happening. I need to actually solve and get an answer for this, though, and make sure I'm right. So here's what I'm going to do to solve. I'm going to add 1 to the other side. E to the 2 sine of t is less than 1. And then to get rid of an e, I'll natural log it. So I'm going to use natural log here. And e and natural log cancel. So I have 2 sine of t equals is less than the natural log of 1, but the natural log of 1 is 0. Divide the 2 away, and now I'm just asking myself, when is sine less than 0? And so I can actually figure this out. I know when sine equals 0, it's at pi, 2 pi, 3 pi, 4 pi, which tells me that when time equals pi, 2 pi, 3 pi, 4 pi, kind of etc., is when this function equals 0. So up on my graph up here, that's going to help me figure out these numbers. When I look up here, pi is 3.14. So I'm going to guess that this first root is at pi. I'm going to guess that the next root is at 2 pi. I'm going to guess that the next one is at 3 pi. And the next one is at 4 pi. I'm going to guess that's where these are, each of these points. So we got pi, 2 pi, 3 pi, 4 pi, which means when is the particle moving left? Well, this little interval down here from pi to 2 pi. And then this other interval over here from 3 pi to 4 pi. And I felt like this one was kind of tricky because there's actually a third interval that you can barely see. If you look at your calculator, it kind of looks like right at 16 it drops below, oops, my calculator's off, drops below the axis, just a tiny bit. So I'm going to change my window from 0 to 16. I'm going to make it 0 to like, how about 20? Just make it a little longer because I think that it drops down below one more time. It kind of looks like it. Yeah, right here for a little part. So we got pi, 2 pi, 3 pi, 4 pi, 5 pi. I would say we have one more answer here. At 5 pi, 5 times 3 is 15. So 15 point something to 16. These are the three intervals that the velocity is negative and the particle is moving left. So this is my answer. When is the particle moving left? From pi to 2 pi, 3 pi to 4 pi, 5 pi to 16. So here's my next question. Question C. Now that we've figured that out, find the total distance. Find the total distance. Find the total distance traveled from time equals 0 to time equals 4. So find the total distance traveled from time equals 0 to time equals 4. Okay, total distance is an integral problem. Means find the integral from 0 to 4 of velocity. Integrate backwards. That's what you want to do to get total distance. Since total distance is also an area problem, it's got to all be positive. It's kind of like getting the integral of the absolute value of velocity is what it's really like. You have to look at the graph and split it up if there's positive and negative area. Now we're only going from 0 to 4. So remember what our graph looked like? I'm redrawing it here. There was 4 and 8 and it kept on going, but it went up like this, came down, went back up, came back down, and it crossed the axis right here at pi and 2 pi. We're finding the area from 0 to 4. So that means starting at 0, all of this area, and going to 4. It's a two integral problem. We're going to have to split this up a little bit. It's close to being a one integral, but there's a little bit of negative area. So really it's going to be integral 0 to pi of velocity plus integral from pi to 4 of velocity. And because this little bit of area down here, this dark space from pi to 4 is in the negative, I'll put a negative sign in front of this integral. And that's the thing I got to solve. So this is really integral 0 to pi of, we'll plug in the function, e to the 2 sine of t minus 1 dt minus integral pi to 4 of e to the 2 sine of t minus 1 dt. Thankfully, it's a calculator section, so I don't have to solve this by hand. I'm ready to plug it into my calculator, store the numbers, and combine them. So this first integral, I solve it on my calculator and get 10.106 something. I store the number, subtract, I do the next integral in my calculator, I get negative 0.435 something. Store it. We're going to combine these together. A negative negative will add them up to 10.542. The total distance this thing travels, total distance is 10. 10.542, and it might be meters or feet. I don't really know what's traveling, but it goes 10.542 something units. So, one last question for you. Question D. It's going to look like this. Is there any time, which I'm going to say t, is there any time t on the interval 0, so on 0 less than or equal to t less than or equal to 16, which the particle returns to the origin. Returns to the origin. Justify your answer. Justify your answer. So, is there any time t for which the particle returns to the origin? Justify your answer. The particle started at the origin and then it starts moving around, has positive and negative velocity. So the question really is, does displacement ever equal 0? Does displacement ever equal 0? That's really the question. Remember what displacement is like if you're at your house, here's your house, and you go on a jog and you jog 4 miles this way. And then you turn around because you're tired and you jog 4 miles back. You jogged a total distance of 8 miles, but you were displaced 0 because you started and ended at your house. You ended and started at the same point. This is the origin. They're saying, is there ever a time when the particle returns to the origin? Well, if that happens, then the miles that you run, you have to return back. So displacement has to equal 0. Now, displacement is found with an integral. It's the integral of velocity. And displacement is just a regular integral with not having to worry about area. So, I guess we're asking, will we ever get 0 equal to the integral of velocity dt? Oh, sorry, this should be a t. And there's bounds in this integral. We're saying somewhere from 0 to 16. So at 0, you start at the origin. We're going to say, are you ever going to return back from 0 to time, I'll call it time capital T. I'm going to put a variable inside of here. The reason I'm doing that is I could tell you that it takes 3 minutes before I'm back at the origin. So the integral from 0 to 3 is my displacement back to 0. I don't really know. I guess the big question is there any number I could put in here to get velocity, the integral of velocity, to be 0? So what I'm going to say is the answer is no. For all values of t on 0 less than or equal to t less than or equal to 16, displacement will never equal 0. Displacement will never equal 0. The reason I know that this answer is right, or how this works, is displacement never equals 0 because look back at your graph at all these velocities. Positive velocity means it's going right. Negative velocity means it goes left. So we got it's going right, it's going right, it's going right, it's going left. It's going right, it's going right, it's going right, it's going left. If you look at this graph, there's a lot of going right. Lots of positive velocity. There's only a little bit of negative velocity. So this thing goes to the right, to the right, to the right, to the right, to the right. Okay, so goes to the right, and then for just a little bit goes left. But then it stops and starts going to the right, to the right, to the right, and then for just a little bit goes left. This is the little bit going left. And then it goes right, 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 a little bit left. I'm going to say, just logically thinking about this, it's never going to get all the way back to where it started at the origin. So that's how I know my answer. That's how I know for all values of t on this interval, displacement's never going to equal 0. I just have to state that, and I showed that the integral would be equal to 0. And I got my answer. So your job the rest of the weekend is to find some time and do the purple worksheet. It's a motion review. It's 2 AP questions, and we're going to go over the answers in class and practice grading them. It's a 2002 question. Really good one to kind of go through and practice. So work on it and bring it to class on Monday, and we'll